Everybody, Mr. Mack here. I thought I would do number 4, problem from our linear programming practice set. Here we have a craftswoman produces floor lamps and table lamps, and it requires 75 minutes of labor for a floor lamp, and the materials cost $75. Okay, so we've got that's a floor lamp. Table lamp requires 50 minutes of labor, and the materials cost $20. The craftswoman wants to work no more than 40 hours each week and has a limited financial resource of $900 for materials. She can sell as many lamps as she can make with a profit of $39 each, $33 for table lamps for a profit. How many floor lamps and table lamps should she make each week to maximize her weekly profit? Well, this is very similar to the other example problem we did, example 1. So I encourage you to use that as a model. That's why we do examples, so you can go back and use it as a guide. This one's very similar. So what are the independent variables here? Well, we don't know how many floor lamps and table lamps she should make. So this is really what we want to find out. So let's let x equal the number of floor lamps and we'll say y is the number of table lamps. That she's going to make weekly. All right. So, I put a chart to help organize information last time, but we have a couple of constraints here. So let's take a look at the time constraint first, right? So it takes her 75 minutes to make one floor lamp. Well, one floor lamp we're calling x. So 75 minutes times x this is the total time it's going to take in a week to make floor lamps, all right? So this is the time for all floor lamps for the week. Floor lamps, right? And we're going to add that to the time it takes to do a table lamp. It takes 50 minutes to do one table lamp. And here are the number of table lamps we have right here. Is y. So for instance, if we had 2 table lamps, right, it would take 100 minutes. So does she have a limit on the amount of time that she could work? She does. She doesn't work any more than 40 hours. So she can't work more than 40 hours. So we're going to say less than or equal to 40. Okay, but wait a second. You're saying 75 and 50, these are in minutes, and 40 is in hours. So we have a problem here with our units. We either have to make the 75 minutes, we have to turn that into hours, and the 50, or we take the 40 and put it into minutes. I'm going to put the 40 into minutes. So we know in 40 minutes, there are how many hours? So I could have done this, I guess, as a separate problem over here. I could say, 40 minutes, 40 hours. Back that up. In 40 hours, we know we've got 1 hour in 60 minutes. And boy, did I write that small. Okay, so hours are going to cancel. So this is basically 40 times 60 is going to go here. So I could really say times 60 here. And that's going to be 2,400, right? 4 times 6 is 24, and then 2 zeros. Okay, so that's really 2,400. And, I think I'll just go ahead and replace this right here. Just say, whoops, 2,400 minutes. Okay, so this is our time constraint right here. And I'm supposed to be putting this in step 2. I'm supposed to be putting that in step 2. Darn it. So, how about I do that? Okay. So, this is our time constraint. Time constraint. Just going to say CONT period for constraint. Okay, so now there's another constraint here. And that is the cost constraint. She's got a limited financial resource of $900 a week. I mean, we could also say, okay, I know that we have to be within $900 here. So we're going to spend some money to make money, but the spend money is on the left side, no more than 900. So it's got to be less than or equal to 900. So what's our cost, right? It costs $25 here to make a floor lamp. 1 floor lamp. 2 floor lamps would be 50. 3 would be 75. So we're going to take the number, the cost of each floor lamp and multiply it by the total number of floor lamps we have. We don't know what that is. It's X. So that goes there. And then now we have to say, okay, table lamps are 20 times the number of table lamps. So this is going to be 20y. Okay, so this is our, let's call it our cost constraint, our limiting constraint for our financial resources. Okay. Now, we also know that she's going to produce more than or equal to 0 floor lamps, and same with table lamps, right? I mean, she's not going to produce a negative number. So this puts us, in quadrant 1 here again. So we're in Q1 for this. Okay. So we got our constraints, and we need to find the objective here and translate into, I think I've already got that. So, I mean, we're just going to be looking for our objective function here. I already have our linear inequalities I already have up here. Okay, is this a maximum or minimum optimization problem here? How many floor lamps and table lamps should she make each week to maximize her weekly profit? And how does she make a profit? She gets $39 for floor lamps and $33 for table lamps. Okay. So that means we're going to set up a new variable here. We say z equals, and we're going to say this is her profit. All right. Profit. So z is going to be based off of $39 for each floor lamp. How many floor lamps do we have? X. So 39 times X is going to give us how much money we make on floor lamps. So we're going to add that to 33y. Okay, there is the objective function. That's done. All right, so the next step is to graph the region of possible solutions. Okay, so we have to graph all of our constraints here. There's 4 of them. We have a time constraint, we have a cost constraint, and then we have our minimums here for our floor and table lamps. So we need to do a little bit of work here. And so let's take our first equation here, and I'm just going to pop up over here. We've got 75x plus, I'm writing this really small, 50y is less than or equal to 2400. Okay, it's Let's zoom in on this now. Okay, we got this. Let's solve for y. Okay, so y is less than or equal to, so we're going to get here 75 over 50. That's going to be, well, I can divide out 25 top and bottom. That's going to be negative 3 over 2x. All right, plus 2400. Let's see, zeros cancel there. 5 goes into 24 4 times. Bring down 4, 8, 48. Okay, so my y-intercept is 48. My slope is negative 3 over 2. I'm going to go down here and we're going to plot this. I didn't give you guys graph paper. You got to use your own. 45, 46, 47, 48, 49, 50. Okay, so I'm going to start at 48, 46, 47, 48. And then we're going to go down 3 over 2. Okay, I got a few points there. I'm going to get my line tool. Gosh, I think I got to do a few more points. So hard to see. Just want to make sure that I don't mess it up. 3 over 2, 3 over 2, 3 over 2, down 3 over 2. All right, I really do think I have enough now. Yeah, I've gone all the way down to the bottom. So I just really want to make sure, because we know when we find our corner points, we want to have some precision so that we're going to substitute the right points into our function. All right, here we go. Now, we need to find the shaded side. And so let's test 0, 0, which is, the origin. Boom, right there. Let's test that by plugging it back in here. And I think we're going to see it's true, right? It's pretty obvious. 0 cancels that, 0 cancels that. Is 0 less than 2400? Yeah, it is. So the shading on this ends up being on the inside here. And let's see here. What if we make a very light shaded region? Can I even do that? Or does it just go really crazy here? Oh, yeah, it's just going to be tough to do. All right. So we'll do this banana color. And can I get a brush? No. Okay, no brush. So just put some arrows. We're shading on this side. Next one. Gotta keep this thing moving. All right, so now we need to do our cost constraint. 25x plus 20x is less than or equal to 900. You know what? Let's just copy this thing. Copy that. And let's bring it over here. And zoom in. And let's solve for y. Subtract 25x to both sides. And divide by 20. Y is less than or equal to, okay, we could take a 5 out of top and bottom here. 5 and 4. And when I cross the zeros, 2 goes into 90 45 times. My B is 45. My M is negative 5/4. And somebody's coming into my room. 45. What's up?
Alright, I have this bearing directions thing, and I didn't do the last one. I was gonna ask you for like some help on it, if you can. But can you like check the others and see if it's
Maybe in a while. Can you just leave it there? Or I'll come down and check on you in a bit.
okay?
1, 2, 3. I'm a bit busy at the moment. 1, 2, 3, 4. Down 5. 1, 2, 3, 4. Down 5 over 4. Down 5 over 4. Down 5 over 1, 2, 3, 4. And 1, 2, 3, 4. Okay. There's our line, and we're going to do shading, and I think we'll see it's just the same situation here. We test 0, 0. 0 is going to cancel on both of these, and we're just going to get zeros less than or equal to 900. That's true, so we're going to be shading this direction. And so our x is greater than 0 is going to be everything to the right. Our y is greater than 0 is everything up. And so our shading is going to be, I guess let's thicken this up. Everything in here. Okay. So now we need to determine our, a little bit over here. We need to get our corner points now. And so we've got 0, 0 is a corner point. We have a point right here. Let's call this one, this is P1. P2 is going to be 0. We know that's 0, 45 because that was the y-intercept on the blue line there. We've got this point right here, P3. P3 is not so clear what P3 is. Looks like it's maybe 12, 30. And then we have another point here, P4. Not terribly clear there either. So we need to determine P3 and P4 a little bit better. So P3 is where our two blue lines intersect right here. So I'm going to take these two equations and copy them down here. And I'm going to, instead of making these inequalities, I'm going to make them equal so that we can then solve them, solve the system. It's basically saying, where do these two lines intersect? They intersect there. We know there's a solution. We just need to get a little bit more accurate point there because the way we've got it now, it's not helping us out. So let's see if we can eliminate one of these variables. Now, I think the easiest one to get rid of is x. If we multiply this equation by -3, this will give us -75, which will cancel with this 75. Okay, so we don't do anything to the the red equation. I'm just going to leave that one alone. Let's multiply -3 through everything here on the blue. That's going to give us -75x. -3 times -20 is -60y. -3 times 900 is going to be -2700. Right? -3 times 9 is -27 and 2 zeros. And we're going to add these equations. This cancels. We get -10y equals -300. Divide both sides by -10. Y equals 30. Okay, We thought y was going to be 30, didn't we? I mean, this looks like it's at 30, doesn't it? So 30 looks reasonable. Now we have to find x. Let's reuse the blue equation. 25x plus 20 times 30 equals 900. Right, I just took the 30 here for y and substituted in for the y variable here. And 20 times 30 is 600. $25x equals 300. Divide both sides by 25. And x is going to equal, what is that, 12? All right, so there are 25, there are 4 25s and 100, so there would be 12 and 300. Okay. That doesn't make sense. Hold up. So 300 divided by 25. Yeah, that is 12, isn't it? Does that give us, does that work? Let's go back up. Are we 12? Oh, yeah. That looks like it could be 12. Yep. I'm happy with that. So we get 12 and 30. All right. So we need this last corner point on the red line. So this value for y here on the red line, we know is 0, right? Let's zoom in. We know this point is some x, 0 for y, right? Right here. 0 is y. So for the red line, if we were to substitute 0 for y, and that's a red line right here, we could figure out what the x value would be. So let's copy this red line again. There it is. Just copied that. And we are going to substitute y equals 0, and we're going to find x. And then we'll have that point. All right, so we got 75x. This is 0, right? I mean, when we put 0 in for y, that just cancels that. Equals 2400. And so 75x equals 2400. And then we're going to divide 75 into 2400. And that is 32. And I just use a calculator just to facilitate this. Going a little long. 32. Okay, so we go back up here. We know, yeah, that looks like 32. So we're at 32. We just confirmed it. Okay, we have all of our corners here. We're going to now take the corners and substitute them into our optimization function. And so we're going to check 0, 0. We're going to check, what else we got? I forget already. 0, 45. What was that on? 12, 30. And then the last one we do it was 32, 0. Okay. Just double check. 12, 30, and 32, 0, right? So let's put it in. 39 times 0 plus 33 times 0. $0. No surprise. If we don't make anything, we don't sell anything. So this one, we're making 0 lamps of, I forget what type. And this one, we're going to make 45 lamps. And so 33 times 45 is 1485. So this is 1,485 $485. All right, next one, we got 39 times 12. So we got a little bit of a mix here, right? We're going to make 12 lamps and 30 lamps of the other sort. 39 times 12 plus 33 times 30. We get 1458. Okay, and then the last one, we're going to make 32 of the $39 lamps. I'm not going to make any of the $33 lamps. 39 times 32, 1248. Which one is the biggest number? The biggest number is this one, and that's supposed to be a rectangle right there. So she shouldn't make any floor lamps, right? And just make all the other kind of lamps. The crafts woman should make 0 floor lamps and 45 table lamps for a profit of $1485. There it is. Let's put that in plum. 4 table lamps. What did we use for table lamps? Was that blue? And then floor lamps was red. Let's do that. Boom. And bring it down, or bring it up. Bring it up, hopefully. There it is. And that's our answer. Okay. Very good. I don't think I have any more for this problem. That's it. So I hope that makes sense. Or I hope, it's starting to make sense. And I'll see y'all later.